Hello everyone, this video covers chapter 5 from the textbook. So this will be chapter 5, and the main topic is options, and we're gonna do options multiple times during the class. So chapter 5 is just basically an introduction what options are. In chapter 7, that's when we start computing how to find auction pricing. So the first natural question is, what is an option? So an option is a contract, okay, which gives you the right, but not the obligation. So that's very, very important. So you have the right, but not the obligation to do something at a future day. Now there are multiple types of options. The most common one, which is the one we're going to talk about right now, is called European options. So you have European. You can also have American options, exotic options, which is technically a combination of more than one type. You can have Asian options, Russian options, and so forth. Now the class is going to focus mainly on European and American, and we will see a few examples of the rest. But this will be the focus of the class, and we're going to start with the European, which is in theory easier. Well, not in theory, it's a lot easier to compute the prices than American. Right, so let's start with the European option, which sometimes are just called plain vanilla options. An European option contract specifies the following. The seller of the option, which is going to be called the writer, and notation or terminology is important here. So the seller of the option is going to grant the buyer, which the buyer is also called the holder of the option, the right to either purchase, if it is a call, from the writer, or sell to the writer if it is a put, a stock, or any other underlier. At the current stat price, which is going to be called ST, for a prescribed value of K, which will be called the strike price, at the expiration day, which is also called maturity time, T, in the future. Note, only the writer of the option, only the writer has an obligation in this contract. The holder has the option to whether to buy or not to buy, or sell or not to sell, and therefore he has to pay a price for that, which will be called the price of the option. We will get into the pricing, I believe, is in chapter 7. Okay, let's look to an illustration of the payoff functions for a call, and then we'll do the same thing for the put. So let's say that you have there's a gold bar, and somebody agrees to buy for $100 in 1 year. Okay, so here K will be equals to 100, and T is equals to 1 for 1 year. Okay, so let's look to the call option from the point of view of the holder. Okay, and this will be ST, which, remember, this is the market price at time T. Okay, and let's say that K, which in our case is equals to 100, is here. Now the payout function for for the call option from the point of view of the holder will be the following. It will be st minus k plus, and this is new notation, and this is the same thing as the maximum of st minus k or 0. And let me explain what that really means. So remember that the buyer has the option to buy a gold bar in 1 year for $100. Now, if let's say that the price of gold in 1 year is equals to $40, so therefore there will be no point of you paying $40. I mean $100, because you had to pay $100 for something that is worth $20. So in that case, any number below this, it will be called OTM, which means out of the money, which means you're not making any money. Now, if you are exactly here, that will be called at the money, or ATM, at the money. Now, if the stock price is more than that, let's say is 120, then you will definitely buy it, because you will pay $100 for something that is worth 120. So then if this is the case, then this part, once it crosses K, this will be called in the money. Okay, so this part will be in the money, which means this is the part where you will be making money. Here, this axis is the payoff, which remember is f of st. Okay, now let's look to this notation. So this means you either select two things, 0 or the maximum of st minus k. And you can see that this is identical to this. For example, if the stock price or the gold bar price in 1 year is $40, why will you pay $100 when you can buy it for 40, right? So therefore, at that point, you are out of the money, so you make $0 because you are not want to exercise the contract. But if it is more, then you will exercise it. It will be in the money, and your payoff will be 120, which is st, minus k, which is 100. So it will give you 20. Okay, so it's self-explanatory what this notation should mean. Okay, so now let's look to the payout function for a put option. Remember, the put will give you the right to sell, and again we're looking from the point of view of the holder. So here the payout function is going to be now k minus st plus, which remember what this means. This is the maximum, k minus st and 0. So again, assuming the theta k is 100, now this part will be out of the money. Why? Because let's say that the price of the stock is 130. Why will you sell something for $100 if it is worth 130? So you may as well you sell it for 130. So in this case, this will be out of the money. So you will stay with 0, what that means. But if the stock price or the gold bar price is less than 100, let's say is 60, then now you have the right to sell something that is worth $60 for 100. So therefore, the maximum you can make, it will be 100, assuming say the price of the gold bar goes to 0. well, you have the right to sell it for 100, so you will make $100. So this will be in the money, and again, at exactly here, it will be at the money. All right, so now let's look at the profit and loss. First, we'll do this for the call, and then we'll do it for the put. So let's say the C, and this is the standard notation, will be the price of the call, which means that's the premium you had to pay to have the right to buy something. And let's say this is the price of the put, which will give you the right to sell something. Okay? So now let's say this is the profit. Okay? And let's take a look at this from this will be for the call. And let's look at this from the point of view from the holder first. And then we'll do the same thing from the point of view from the writer or the seller of the call. Okay? And to make life very simple, let's just say that the price of the call was $3. Okay. Again, in chapter 7, I believe that's where you'll learn how to find this value. Let's say that the value for K is $100 still. So if the call is out of the money, then you had to pay the $3. So you will lose $3. Because remember, you're not going to exercise anything if it's less than K, because the payout function, remember, was f of st was st minus K. But if it is worth more than $100, then you will exercise, but you still have to pay the $3 no matter what. Okay. Therefore, here you have a limited loss, because you will lose technically only the premium. If the stack price is here, you don't exercise, so you lose just the stack price. The option price. That's it. And this has the potential for unlimited gain or unlimited profit. Unlimited in the sense that if tomorrow, which is unlikely, let's say the price of the stock went to $1 million, well, you still have the right to buy for $100, so you will make almost $1 million right away. Okay, so in theory, it is possible. All right, so now let's look to the same call, but from the point of view of the writer. And let's say again the K strike price is here. Let's say it's $100 again. So remember that if the price of the stack is less than K, the holder is not going to exercise. So therefore, when the value is less than K, the writer, no matter what, is going to get a C, because that's the premium that the holder has to pay to enter into the contract. But if the price goes higher, then the writer can lose the money, because he has to sell something for $100, which potentially could be worth a lot more. So this is ST. So therefore, from the point of view of the writer, he has a limited gain, which is technically the premium that the holder has to pay, and potentially could have an unlimited loss. Okay, now let's do the same analysis, but for a put option. So again, let's look first to the holder. Remember that the holder now has the right to sell. Okay. Again, let's say that the value for K is here. So remember, you're not gonna sell something for $100 if it is worth $200, but you will sell something for $100 if it is only worth like $20 or $30, right? Or if it is in the money. So the easiest way to look at this is just you will sell if it is in the money, and you will not sell if it is out of the money. Now remember, to enter in this contract, you have to pay a premium of D, because that's the price of the put option. And the reason for using D instead of P is because we're going to use probabilities later, so it's very easy to get confused with the P. So D will be the price of the put option. Okay. So up to this point, you will make money, but the money that you will make, or the profit, will be K minus D, because you have to pay for the premium. Okay, so this will be the profit, and after that you will just lose the premium, because you're not gonna sell anything after that. So therefore this has limited loss, but also limited gain. Okay. Now from the point of view of the writer, this is what will happen. You have D here, so he will get D if you don't no matter what, whether you exercise or not. But if you exercise and the price is less than K, the writer will have this money left, or will lose this money. Now the next obvious question is, why do you want to deal with options? Okay. Now options are technically used for three main things. They're used to generate income. Okay. Or to speculate. So speculate just means you're placing a small bet, hoping that something is going to happen in the future. Or to hedge, so which means it's a protective strategy. So these are the main three reasons why options exist. But let me give you a very simple example why options in theory are a great idea. So let's say that the price of the Apple stock today is $100. Okay, so let's say the Apple today is 100, which is actually like 130 something. But okay, let's say that's the price of Apple. So let's say that in 6 months, if that was the time you agreed to, this is 120. Or let's say that it went down to 80. Okay. So therefore, if you had buy the stock, then you automatically make $20 if you only have the stock. But if it went down, you will lose $20. Okay? Now, let's say that if you were to buy an option instead, and let's say that you paid $3 for the option, then if it went up, then your profit was $17. But if it went down, then you only lose the $3. Okay, so this is one of the reasons why options are a good idea. Or let's say that the price went to $140. So let's be more extreme. So if you buy the stock only, you make $40. But let's say that the stock went down to $10. So then you lose $90. But if you had buy an option for $3, well, then you had made $37 in here, and here you only lost the $3. Okay? So this is why options are very popular. One of the reasons why they are popular. All right, now let's look to the put call parity. which this technically will give you a relationship between the put and the call option prices. So meaning if you know one, you should know the other one. Remember here that K is the strike price, okay, and T will be the expiration time or maturity time, okay, and R obviously is always the interest rate, and unless it specify otherwise, it's usually always continuously compounded. We will be using the following notation the whole semester. So CT is gonna denote the call price, and by call it means always option in this case at time T. DT will be the put price at time T. ST will be the stock price at time T. BT will be the money in the bank at time T, okay? And BT, this is the new part, is gonna be the portfolio. So portfolio is just a combination of calls and bank accounts, or calls and the stacks, okay? So this will be the portfolio value at time T, okay? Time T. All right, so let's look to the first portfolio here. So the one is gonna denote that is the first portfolio. The notation is a little cumbersome, but this is technically the one that the book has, so we had to go with that. So this is the first this denotes the first portfolio. Okay. So here, this is a combination of a call plus the bank account. Okay. So then what will happen at time T, which remember that's the expiration time. At that time, the value of the call, it will be ST minus K plus, and the value of the bank account is going to be E to the R T minus T. Remember, it's the interest you will get from the account. So all of this is BT. Okay, so this has two choices. This will be just E to the R T minus T BT if the value for ST is less than K, or it will be ST minus K plus the money on the bank if, okay, ST is greater or equals to K. Right, so now let's look to the second portfolio. Now this portfolio has a put option and a stack, the actual stack on it. So therefore from here BT2 will be equals to either K minus ST, since this is a put, plus ST, because that will be the price for the stack at time T. Again, this one also has two choices, so this will be either K if ST is less than K, or this will be ST otherwise. Now, if the value of the bank account is equals to the strike price, then the first portfolio will be equals to the second one. Okay. So then from here we will get the put, call, parity, which will be the following: ct plus k e to the minus r t minus t, it will be equals to dt plus st, okay? Which implies that ct will be equals to dt plus st minus k e to the minus r t minus t. Now this assumes there is no dividends from the stack, okay? And this implies no arbitrage, which, remember, that's the goal of the whole class. So if this doesn't hold true, then that means there is an opportunity to make money for free, and that's what the next example will be about. All right, so let's look to this example. Let's say here the stack price right now is $40. The interest rate is 5%, and you can buy a call for $3 or a put for $2 with a strike price of $40, and the expiration day is 1/3 of a year. Okay. All right. So now, because of the put call parity, we should be able to figure out what D0 is. Okay. So D0 should be C0 minus S0 plus K e to the minus RT. So in our case, it will be 3 minus 40 plus 40 e to the minus 0.05 times 1/3. And this is around 2.34. All right, so here we have two different prices for D0. Somebody is willing to sell it for $2 when the actual price should be $2.34. Right, so what should the strategy be to make money, since there is an arbitrage opportunity here? So let's say that this represents t equals to 0, and this will be the expiration time, which is 1/3. Okay. Now there is multiple ways to do this. Okay, this is the same example they have on the book, I believe. So I'm just gonna follow what they have there, but you can do this in more than one way. So the first thing you can do is you can be a writer, and you can write a call. Okay, so it's very important that you understand the terminology. So you write a call. So right now you're gonna get a $3, okay? Because you are the writer. So you will get $3. So up to here is T0. Okay. Now, what happens if the value of the strike price is $40 or less than $40? Well, you're not going to lose any money, so it will be 0. But if it is more than 40, then the value here will be 40 minus ST. Then the next thing you can do is, well, just buy a put. Since you're the one buying, so now you're the holder from this one, you will lose $2. And what happens if the value of the stack is less than $40? Well, this will be what you get. In this case, you will get 0. Then you can also buy one stack. So right now it will be minus $40 because you have to pay 40 for the stack. If it is less than this, then you will get ST, and it is here, you will get ST. You will get whatever is the price for the stack at that point, right? And then you can borrow money. Now the goal is to get 0 here. So that's the goal. So therefore, you will need to borrow $39. Okay. Now, since you're borrowing money, you have to pay it back. So in one third of a year or 4 months, you have to pay back now $39.65 because you borrow the money, the interest rate is 5%. So you can calculate that easily. So you will have this much money left, 34.5. This value should be the same, and you will end up again with 34, pretty much 35 cents. So by using this strategy, you automatically will make 35 cents, which doesn't sound like much, but if you multiply this by 1,000 or 1,000,000, then it will be a lot of money. Now, there are five quantities that will determine the price of the call or the put. Obviously, the strike price, the expiration day, the value of the stock right now, the interest rate, and one that we haven't looked at yet, which is the implied volatility. So these are the five variables that influence the price. So now this is what happens all the time, and you should check this by yourselves. So if you increase, let's say, the strike price, what will happen to the price of the call? Okay. And which is, remember, this is C, and then the price of the put was D. Okay. So this is the price of the put. So what happens if you increase K? The value for the call will decrease. Again, you should go back to the very beginning and check the payout functions and see why this is the case. Well, the value of the put will increase. Now, if the expiration date increases, then the price of the call will also increase, and the price for the put will also increase. Now, if the stock price increases, well, this will also increase, but now this one will decrease. If the interest rate goes up, this will increase, this will decrease. And now if the implied volatility, which we haven't talked about, increases, then this one will increase, and this one will increase too. All right, so finally, let's do one more example. So at time zero, the investor bought one European call with a strike price of $20 and another European call with a strike price of $40. She also borrowed two European calls with a strike price of $30. All the options are on the same underlying, which means all of them will be like Apple stock or Tesla stock, and all of them have the same expiration time or maturity time T. Okay, so this is called a butterfly spread. So what will be the payoff function for this? Right, so here we have the following: K1 is equals to 20, K2 is equals to 40, and K3 is equals to 30. All right, so the value of the portfolio, it will be CT of K1 plus CT of K2 and minus 2, because you're borrowing these ones of K3. Okay, so let's analyze the payoff function for this. So first, let's say this is the call for 20, this is the call for 40, then you have minus 2, the call for 30. All of this, remember, has to add to your portfolio. So if the value for the stock is less than 20, you will not exercise, so all of this will be will be 0. So this value here will be 0. Now, if the value for the stack is between 20 and 30, then you will get st minus 20 from this one, 0 from this, 0 from this. So the total amount you will get is st minus 20. If it is between 30 and 40, this will be st minus 20. This will be 0. And this will be minus 2 times st minus 30, or 60 minus 2st, which comes to 40 minus st. Now, if the value for st is more than or equals to 40, this will be st minus 20. This will give you st minus 40. And the last one will be 60 minus 2st, which adds to 0. So this will be the value of the portfolio at time t, capital T. So therefore Vt will be equals to technically st minus 20 plus st minus 40 plus, then minus 2 st minus 30 plus. If you do a graph, it look like this. So this is bt, this is s of t. Have 30 here, 20, this 40, and the graph would look like this. Okay? So that's a butterfly spread. And that's it for chapter 5 for now.